Hey everybody. In class late we've been talking about equations and solutions to equations, the value that makes an equation true. Today we're going to talk about how to find the solution to one-step equations. But in order to do that we have to understand a couple properties of equality. The first one we're going to talk about is the addition property of equality. The addition property of equality says that adding the same number to both sides of an equation produces an equivalent equation, meaning that if we add the same number to both sides, the equation doesn't change. So let's say we have A equals B, right? If A is equal to B, then that tells us that if we add a number, let's say we add 5, A plus 5 is equal to B plus 5, right? If I add 5 to both sides of the equation, it's still equal. The left side is still equal to the right side. Okay, think about if we have an equation that says x equals 7, right? Now let's say I add 2 to both sides. If I do x plus 2 equals 7 plus 2, I can simplify that right side to x plus 2 equals 9, right? But since I know that x equals 7, if I put 7 in for x here, 7 plus 2 equals 9, right? This equation is still equal. The left and the right sides are still the same. Understanding this property of equality helps us solve an equation to find the solution, to find the value that makes the equation true, right? If I have this equation, p minus 8 equals negative 3, I can use this property of equality to isolate the variable. That's what we want to do. We want to get this variable all alone so we know what it's equal to. We want to isolate it. Since this says p minus 8 equals negative 3, I know that if I add 8 to both sides, my equation will still be true. But if I do negative 8 plus 8, that gives me 0. And I'm left with p equals negative 3 plus 8 is 5. Now, I can double check this to make sure. I can substitute 5 for p. 5 minus 8 equals negative 3. Now 5 minus 8, I can rewrite that as 5 plus negative 8. And I know that 5 plus negative 8, there are more negatives than positives. Negative 3 equals negative 3. So p equals 5 is the value that makes this equation true. The subtraction property of equality works very similarly to the addition property of equality. If we subtract the same number from both sides of an equation, it produces an equivalent equation. So same thing, if I start with a is equal to b, and I subtract a number from both sides, let's say I do a minus 7, it's still going to be equal to b minus 7 as long as I'm subtracting that 7 from both sides. Okay, we can even start with a numerical example. If I say that n equals 12 and I want to subtract 3 from both sides, I can write n minus 3 equals 12 minus 3, which means n minus 3 equals 9, right? And if I know that n equals 12, I can check this. 12 minus 3 equals 9. This equation is still true, even though I've changed the way it looks. Again, we can use this property to solve equations. Let's say I have p plus 6 equals negative 1. P plus 6 equals negative 1. Once again, I want to isolate the variable. I want to isolate p. What I can do is I can subtract the same value from both sides, knowing that the equation will still be equal, will still be true. So I want to make this 6 go away, so I'm going to subtract 6 from both sides. And I'm left with, that gives me 0, I'm left with p equals negative 1 minus 6, that's the same as negative 1 plus negative 6. Negative 1 plus negative 6 is negative 7. That's my answer. Now, I can always check this by substituting negative 7 in for p, plus 6 equals negative 1. Negative 7 plus 6 is negative 1. So negative 7 makes this equation true, which means negative 7 is our solution. Now, we can use these properties of equality, the addition and subtraction properties of equality, to solve any type of equation that involves addition or subtraction by looking for what's called the inverse operation. An inverse operation is an operation that undoes another operation. And addition and subtraction are inverse operations because they can undo each other. For instance, in my first equation here, t plus 8 equals negative 2. Because I see t plus 8 in the equation, I want to use the inverse of addition, to isolate the variable t, to solve for t. So because it says plus 8, the inverse operation of addition is subtraction, I'm going to subtract 8. And whatever I do on the left side, I can do on the right side to make sure that the equation stays equivalent, stays true. So 8 minus 8 is 0. I'm left with t equals, now negative 2 minus 8, that's like negative 2 plus negative 8. Negative 2 plus negative 8 is negative 10. Okay? And I can check this by taking negative 10, substituting it for t, and making sure my equation is true. Negative 10 plus 8 is negative 2. So this is my solution, makes the equation true. Okay? Our second example here, m minus 6 equals 8, or 8 equals m minus 6. Now, in this case, the operation in the equation is subtraction, so we want to use the inverse, which is addition. So instead of minus 6, the inverse is going to be plus 6. And the addition property of equality says I can add 6 on both sides. So negative 6 plus 6 is 0, and I'm left with m equals 14. Okay, we can check this. 8 equals 14 minus 6. 14 minus 6 is 8. So that equation is true if m equals 14. Now, my third example here with p minus negative 2.2 equals 5.6. Now, I could go about this a couple different ways. I could use the inverse operation of subtraction, which is addition. I could add negative 2.2. Or I could rewrite this as p plus positive 2.2 equals 5.6. And since now I have addition, I can subtract 2.2 from both sides of the equal sign. 2.2 minus 2.2 is 0. We're left with p equals 5.6 minus 2.2 is going to give me a 4 there. We have our decimal, 3.4. Right? And as always, we can check this. 3.4 minus negative 2.2 equals 5.6. We can change that to 3.4 plus 2.2. And that does give me 5.6. So that is my solution. That makes it true. And our final example, negative 6 plus f equals negative 2. Now, I don't really like the order that this problem is written in. I like to have my variables come first because I think it lets me see it a little bit better. So we can use the commutative property of addition. I can write this as f plus negative 6 equals negative 2, right? As long as it's addition, we can move our terms around. Now I can rewrite plus negative 6 as f minus 6 equals negative 2. And now we can use the addition property of equality to add 6 to both sides. Right? Negative 6 plus 6 is 0. So f equals 4. And just in case if we want to check it, negative 6 plus 4 equals negative 2. Negative 6 plus 4, that does give me negative 2. So f equals 4 makes this equation true, which means f equals 4 is the solution to the equation.